So hello everyone, we are again up with a Leetcode problem. The problem name is average of levels in binary tree, and so it's a tree problem, and slowly we are increasing the level. So what the problem states: given a non-empty binary tree, return the average value of nodes on each level in the form of an array. So it's quite easy to understand the problem. Like uh, see at the example, the input is a tree, so the output is of the form of an array. Like you can see the output, the first value of the array is 3. So because there is only one node at the root 3, so you have to return like every index of the array will return the average of the level. So look at the second level of the tree, 20 plus 9, 29, and 29 divided by 2 is 14.5. So the second value in the array is 14.5. Similarly, at the third level, 7 and 15, 7 plus 15 is 22, and 22 divided by 2 is 11. So it's quite easy to understand. Now how to do it? Actually, the implementation part of this problem is a bit tough, not tough, but a bit, because it's gonna use breadth first search. So for those who don't know what breadth first search is, let me explain a bit about breadth first search. So guys, I have taken this tree for explaining the breadth first search, and it's a must. It's a traveling algorithm. It's a traversing algorithm for tree and graphs, and it's kind of very important and is very frequently asked in the interviews. So let's do breadth first search on this tree first, so that you can know what a breadth first search is. So we will start from node, root node. So the value at root node is 1, so we visit 1 first, and we kind of make a tick here that okay, we have visited 1, and write it in output. Now look all the neighbors, all the adjacent nodes of 1. So the adjacent nodes of 1 are 2 and 3. So we can write in output 2 and 3, and write all the adjacent nodes of the current visiting node in the queue. So first I will enter 2 in queue, and then 3. Like this queue will only tell us about the preference, like which node we have to check next. We have started from the root node. Now after root node, which node we have to check. We have visited 2 and 3, so make a tick on 2 and 3, and in output it is written as 2 and 3. Now since we know that queue follows first in first out principle, so the first value that was in is 2, so we will check 2 now. So check 2, check all the neighbors of 2. Neighbors of 2 are 4 and 5, so write it in 4 and 5, make a tick because it's visited, and enter here it in queue 4, 5. And since we have looked up at node 2, so dequeue it, just cut it from here. The next node is 3, so go and check 3, all the neighbors of 3, 6 and 7. So write it in output, make a tick, and add it in queue. So since all the nodes are visited here and the output is this, we dequeue all the elements. Okay, so now there is no need of checking preference, so because all the nodes are already visited. So if you look at the output here, okay, so what was in the question, we have to return the average of each level. So if you closely look at the output, if I divide it in 3 parts, then if I add these two and then divide by 2. Like if I find the average, there is only one node at root, so I have divided it by 1. Then there are two node at level 2, so I have divided by 2, and similarly 4. So if you kindly look at it closely, you will get to know that if I'll do the breadth first search of the given problem, and instead of giving output of the breadth first search, I just add these elements and then take the average and store it in array and return it. That's the problem. Finish. Simple breadth first search. Application of a simple breadth first search, and that is it. So we have to implement breadth first search only in that problem, and let's see how to do it. So let's start with the coding part now. We have to implement breadth first search. So first of all, we have to look at the return type of the function. There we have to return a list. So first of all, let's declare a list of that will store the value of data type double, and I'll call it, name it as result. I have defined an array list, and I am coding it in Java, that's why it's array list. Like in other languages it will be array, or in C++ it might be so like in C++ you can use vector or whatever. So now I'll define a queue that will be a tree node. I'll name it as queue. So for those who are not familiar with Java syntax, it's basically I have just defined a queue in here. There is no need of getting afraid or anything like there are some big terms in here like linked list, queue, tree node. Tree node is basically the class you can look up. So just concentrate on the logic part, remaining else is syntax only, you can easily get it. So if root equals null, if root is null, then we'll return an empty array. Okay, so result is empty right now. Now first of all, we'll start the breadth first search from root. So we will have to add the root in while so while the queue is not empty, there will be this outer loop inside which we will take two variables, sum and count. So the sum will calculate the total sum of the numbers of each level, and count will calculate the total number of nodes at each level for calculating the average. So So in here what I have done is I have simply made an object of tree node, and I have removed the value from the queue, and I have simply added the value in sum, and count plus plus it just after adding each value of node, it just iterates, like it will tell me that how many number of nodes was there in each level. So it's for that. Now for the neighbor part, next neighbors, we will write two if statements. If current so here I have basically added the uh, adjacent neighbors to the queue, like we have done. For example, if you look at here 3, so the next neighbors I have added it is if its current node is this, if its left is not equal to null, then it's added in queue. Similarly, in its right, 20 is added to the queue. So these two statement denotes that only. Now, after this, close the for loop, and after the for loop, so after adding the neighbors, what we next have to do, we'll simply add the average in the result array. So divided by count, and after which we'll simply return the result. So okay, just because the code is a bit long, I'll explain it once again. In the first line I have just declared an array list which we have to return, and in the second line I have declared a queue through which we are implementing breadth first search. Then we have checked whether root is null or not. If root is null, then of course the array list will be empty, so I have returned the array, after which I have added the root to queue. If the root is not null, then we will first start with root, so we have added root in the queue. Then there is a while loop that will check, and that will run actually until the whole tree or graph is traversed, inside which we have declared two variables, sum and count, for calculation of average. Then I have taken the size of queue in a variable, and then there's this inner loop. This inner loop is for each level. The number of levels in this tree are 3, so this loop will run 3 times. Okay, so and then inside which I have simply removed the element and then added it in sum, and count plus plus shows the number of nodes for the calculation of average. And this I have explained earlier also, it will add the neighboring nodes in queue. Then simply have added the value in the result array, and then I have returned the result array. So this look kind of okay. Let's run this code. Okay, basic test cases are passed, so now let's submit it. Bingo. So I'll suggest all of you to do it once by yourself also, because it's very very important as far as coding interviews are concerned. So that was it. See you in the next.